21 March 2019. The research vessel is still an hour out from its usual observation site off Brema Bay, Western Australia, when the crew slows to pull debris from the water. The rain is heavy, visibility is poor. Then, biologist John Totterdell spots the dorsal fins. "Within seconds," he would later say, "we realized they were attacking something big. Then we realized, oh my, it was a blue whale." 12 orcas are already working the animal when the team arrives. The dorsal fin has been mostly bitten away. The flesh along the snout has been stripped to the bone. 3 orcas ram the whale's flank in sequence, while a 4th inserts itself into the whale's open jaw and feeds on the tongue. The blue whale is still alive. About an hour after the team arrives, it dies. That scene is now published in a peer-reviewed paper, Totterdell et al., Marine Mammal Science, January 2022. And it directly contradicts a claim that has circulated widely in wildlife content for years, that orcas won't try to kill an adult blue whale because they are simply too outmatched. That claim bundles 3 separate conclusions into one sentence. Whether orcas are physically capable of killing an adult blue whale, whether they would choose to attempt it, whether they would likely succeed. Those aren't the same question. Answering all 3 requires being precise about what the evidence actually contains and what it still does not. 3 questions, 1 claim. The investigation runs in that order. Pillar 1 is physical capability, and it has 2 sides: what orcas are built to do and what they would be facing. An adult male orca typically measures 6 to 8 meters and weighs more than 6 tons. Maximum recorded males approach 10 meters and 10,000 kilograms. They aren't solitary predators. The relevant unit is always the group. Mammal-eating orcas, called bigs or transient orcas in North Pacific terminology, hunt in coordinated packs, with adult females typically leading attacks and males and younger animals joining in calculated phases. The jaw shape alone differs diagnostically. Bigs orcas show a deeper jaw curvature and a more pronounced convex ventral edge, correlated with biting and gripping large prey. That distinction matters for this investigation because fish-eating residents have no documented large whale kills. Bigs orcas do, repeatedly and across multiple decades. The cooperative mechanics underlying those kills are documented in peer-reviewed detail. A 2025 study published in Current Biology examining Norwegian herring-feeding orcas found that hunting groups divide labor explicitly between what the authors labeled strikers and helpers, larger individuals performing the primary attacks while smaller animals act as barriers and positioning agents. The coordination is geometrically precise and maintained across partners over decades. Antarctic Type B orcas apply comparable group precision to dislodge Weddell seals from ice flows through coordinated wave washing, a technique confirmed to succeed in 86% of documented seal kills. Against large cetaceans, the pattern involves multiple attack angles simultaneously, restricting the prey's options of flight and submersion. A Brewder's whale attack, documented in the Gulf of California, 1988, noted that the orca group attacked areas clear of the whale's tail throughout, a tactical detail that reappears across the large whale kill literature. The documented kill record for large cetaceans is substantial. In October 1997, roughly 130 kilometers off Central California, approximately 35 orcas attacked a pod of 9 sperm whales for roughly 4 hours. Adult female orcas attacked in waves of 4 to 5 animals in what Robert Pittman, then at NOAA's Southwest Fisheries Science Center, described in his 2001 Marine Mammal Science paper as a wound and withdraw strategy. At least 1 large adult sperm whale was killed and eaten. The rest were, in Pittman's words, seriously, perhaps mortally wounded. Ford et al., 2005, documented 9 attacks on minke whales in the Northeast Pacific, 4 of which ended in confirmed kills, including animals taken in open water. Pittman et al., 2023, in Aquatic Mammals, documented fatal attacks on fin whales off Baja, California, one confirmed victim estimated at approximately 21 meters. A Brewster's whale kill off the northern Gulf of California in 1988 was observed directly from a single-engine aircraft and confirmed via video, the carcass located 2 days later with the lower jaw removed. One physical limitation deserves plain acknowledgement. No peer-reviewed study has directly measured orca bite force in a living animal. A 2025 master's thesis from Westchester University applied finite element analysis to a Biggs orca dry skull. A widely cited figure of 19,000 psi has been flagged in at least one educational source as misattributed. No in vivo measurement supports any specific number. Any bite force figure for orcas should be treated as a modeled estimate, not a measured fact. What is confirmed? Orcas have the physical architecture, the cooperative tactics, and the demonstrated capability to subdue large, dangerous adult cetaceans. The capability side of Pillar 1 stands on solid ground. The question is what that capability is being measured against. The blue whale isn't a single animal, it's several. Antarctic blue whales, Balænoptera musculus intermedia, reach typical adult lengths of 25 to 30 meters and weights of 120 to 180 tons. Whaling-era records include specimens up to 33.6 meters, with extrapolated masses approaching 200 tons. Northern blue whales, found in the North Atlantic and North Pacific, typically reach 22 to 28 meters and 72 to 135 tons. Pygmy blue whales, Balænoptera musculus brevicorda, are a recognized subspecies of the subantarctic zone, typically measuring 21 to 22 meters as adults and weighing 75 to 90 tons. Female pygmies reach sexual maturity at approximately 19.2 meters. Males average 21.1 meters at full size. That last set of numbers matters enormously for what follows. Blue whale blubber, measured directly in whaling-era discovery reports from Antarctic specimens, reaches maximum dorsal midline thickness of approximately 7 to 8 centimeters. Popular sources sometimes claim up to 4 feet. That figure isn't linked to any peer-reviewed measurement and substantially exceeds what was actually recorded. The blubber layer's primary biological functions are thermal regulation, energy storage, and buoyancy, not armor. No published study has tested its mechanical resistance to biting force. The blue whale tail fluke spans approximately 7 meters across. A hydrodynamic model published in the Journal of Experimental Biology estimated that a feeding lunge by a roughly 25-meter blue whale requires approximately 63 kilonewtons of fluke thrust. Whether that force translates to a protective defensive strike is a separate question, and no documented case of a blue whale injuring an orca with its tail during an attack appears in the peer-reviewed literature. The maneuverability study that confirms large whales outperform expectations for agility relative to body size does not change that absence. Maximum confirmed blue whale swimming speed from satellite tag data sits at approximately 27 kilometers per hour. Higher figures in the range of 32 to 48 kilometers per hour appear in older secondary sources and conflict with the more rigorous tag-measured data. Orca burst speed from tag-based and observational literature reaches approximately 56 kilometers per hour over short distances. The speed gap is real, the size of it's uncertain. The primary defense documented in the systematic literature is flight. Ford and Reeves' review of baleen whale anti-predator strategies found that blue whales fled at high speed in every documented encounter with attacking killer whales. Crucially, no defensive actions, including tail strikes at attackers, were recorded even when animals were repeatedly bitten and large quantities of blubber and flesh removed. The Ford and Reeves review classifies blue whales as high-speed flight specialists, contrasting them explicitly with humpbacks and right whales, which sometimes actively turn to confront attackers. Scarring studies in the Gulf of California found that approximately 25% of individually identified blue whales bore rake marks from killer whale teeth, demonstrating that attacks occur regularly and that most don't result in death. The whale runs. The orcas follow, or they don't. That pattern anchors the second pillar, willingness. The historical record before 2022 contained sustained, documented attacks on blue whales without confirmed kills. A widely cited observation describes approximately 30 killer whales attacking an 18.2-meter blue whale for roughly 5 hours before breaking off without killing it. In November 2016, 10 killer whales were observed off Peru, closely flanking a blue whale in what researchers from the first direct observation of killer whale attacking baleen whales in Peru described as predatory behavior. Outcome unspecified. In 2017, drone footage captured orcas attacking a large blue whale off Monterey Bay, California. The whale accelerated and escaped. Gemmell et al. 2015, published in Aquatic Mammals, documented a severely injured blue whale off Sri Lanka with extensive toothrake marks, a near-missing dorsal fin, and abdominal wounds consistent with killer whale attack. Survival or death not determined. No published study demonstrates orcas systematically avoiding adult blue whales as a behavioral pattern. The Peru observation added a new geographic record. The Monterey footage, frequently cited as evidence orcas can't kill adult blue whales, is actually evidence that orcas pursued, attacked, and were repelled by one large blue whale on one occasion in 2017. That isn't categorical. The mammal-eating ecotypes most relevant to large whale predation have been documented pursuing adult blue whales across multiple ocean basins across multiple decades, often abandoning attacks rather than completing them. Whether break-offs reflect capability limitation, tactical recalculation, or energetic cost-benefit decisions can't be determined from observation alone, and the literature does not resolve between those three explanations. The predator ecology framework that best organizes this uncertainty comes from MacArthur and Pianka's 1966 paper in The American Naturalist, and from Stevens and Krebs's foraging theory, published by Princeton University Press in 1986. Optimal foraging theory treats injury risk as a genuine foraging cost, equivalent in principle to energetic expenditure. Predators weigh that cost against expected returns when selecting prey. The killer whale literature contains explicit documentation of that weighting in behavior. The 1988 Brooder's whale kill paper noted that orca attackers consistently targeted areas away from the whale's tail, specifically because it represented a potential source of injury to the predator. That tactical choice, choose the part that can't hurt you, is risk management expressed in hunting behavior. It isn't the same as avoidance of a prey type. It's selective engagement with that prey type. Attacks on confirmed large, healthy adults are rare in the documented record relative to attacks on calves and juveniles. Long-term photo ID studies on humpback whales find killer whale rake marks present primarily on individuals first identified as calves. Most serious predation pressure arrives early in life, before prey animals reach adult size. Multiple reviews confirm that grey whale adults are far more rarely killed than calves or yearlings, and that attacks on adults are frequently abandoned. Whether that rarity in adult blue whale kills reflects genuine cost-benefit calculation, genuine inability to land a killing blow on a fully healthy large adult, or simply the fact that most of the ocean is unobserved, can't be disentangled from the current data. What won't try can't mean that attacks on adult blue whales don't occur. They do. Won't try is factually incorrect as a universal claim. Which brings the third question, and the 2022 paper that changed the answer. On 21st of March 2019, approximately 21 kilometers off Brema Bay, 12 to 14 orcas killed and ate a blue whale. The victim was estimated at 18 to 22 meters in length and explicitly described by Totterdell and co-authors as an apparently healthy adult. Approximately 40 to 50 additional orcas joined to feed on the carcass. The tactics documented with photographs and video include the dorsal fin bitten largely away, large sections of skin and blubber removed, severe head wounds with bone exposed on the snout. One adult female orca inserting her head into the whale's open jaw to feed on the tongue. Adult females led the initial attack, consistent with the pattern observed across other large cetacean kills by mammal-eating ecotypes. At least 16 of the same individual orcas, identified by photographic comparison, were confirmed to have participated in all 3 events recorded in the paper. 16 days after the first kill, approximately 25 to 30 orcas from the same population killed a blue whale calf estimated at 10 to 12 meters. On 16th March 2021, 12 orcas initiated an attack on a 12 to 14-meter animal described as a young juvenile, with up to 75 orcas joining as the event progressed. All 3 victims were killed and consumed. John Totterdell described the findings as having lifted the bar way higher than I would ever imagine. Robert Pittman told Science News, "This is the biggest predation event on this planet, the biggest apex predator taking down the biggest prey." Now, a distinction that determines what the evidence can and can't establish. All 3 Totterdell victims were pygmy blue whales, Balanoptera musculus brevicorda. The confirmed adult kill was a pygmy, estimated at 18 to 22 meters, and most likely in the range of 75 to 90 tons. A typical adult male orca at roughly 6 tons against an 80-ton pygmy adult is a mass ratio of approximately 1 to 13. Against a 150-ton Antarctic adult female, that ratio extends toward 1 to 25. Against a maximum Antarctic specimen, the ratio approaches 1 to 30. Those aren't the same predation problem. Treating them as equivalent is exactly the imprecision the original claim contained. Pittman isn't incorrect that it is the largest documented predation event in the modern record. The prey was, however, the smaller subspecies in a region where those animals are routinely observed by a population of orcas. All 3 events occurred at the Bremer Canyon continental shelf drop-off, 21 to 50 kilometers offshore, regularly accessed by research and whale-watching vessels year after year, one of the most intensively monitored cetacean hotspots in the southern hemisphere. That context does not diminish what happened. It contextualizes how it was observed and raises the legitimate question of how much remains unobserved elsewhere. A possible 4th event, reported by ABC News Australia in April 2025 and described by the whale-watching operator Naturaliste Charters, involved approximately 60 orcas attacking an estimated 18-meter pygmy blue whale over roughly 90 minutes off the same coast. That report, from a single news source without an associated peer-reviewed publication as of available records, adds a data point but not a confirmed peer-reviewed finding. The evidence for confirmed kills extends to confirmed adult pygmy blue whales. It does not extend to Antarctic or northern subspecies adults. No attack on an Antarctic or northern adult blue whale with an observed outcome appears in the peer-reviewed literature. Absence of observation in the deep, remote ocean isn't proof of impossibility. It's an evidence gap. Orca predation on blue whale calves is separately documented, the second Totterdell event. A blue whale calf at 10 to 12 meters is approximately the same length as a large adult male orca. That is a fundamentally different predation problem from attacking a 22-meter adult, which is itself a different problem from a 30-meter Antarctic specimen. The biology scales non-linearly. Calf evidence can't be extrapolated to adult conclusions, and calf predation is outside the scope of this investigation. The ruling emerges from what the evidence has established across 3 distinct dimensions. Physical capability. Orcas, specifically mammal-eating ecotypes including bigs and their ecological equivalents in the southern hemisphere, have confirmed capability to kill large adult cetaceans, including adult sperm whales, adult fin whales, adult Brewers whales, adult Antarctic minke whales, and adult pygmy blue whales. Every confirmed kill uses cooperative group tactics. No single orca has killed a large whale alone in the documented record, and that isn't incidental. The cooperative structure is the mechanism. Bite force remains unquantified in any peer-reviewed in vivo study. That absence does not alter the documented outcome record, but it should be stated plainly rather than papered over with unverified numbers. Willingness. Orcas in mammal-eating populations have attempted to kill adult blue whales on multiple documented occasions, across decades and ocean basins, with outcomes ranging from successful kills to prolonged chases that ended in the whale escaping. Won't try as a categorical claim is contradicted by the observational record. What the record shows is that such attempts are rare relative to predation on younger, smaller animals, consistent with the cost-benefit predictions of optimal foraging theory, but they occur. Likely outcome against an adult blue whale. Confirmed successful against adult pygmy blue whales, at least 3 times in peer-reviewed literature and possibly a 4th in news reporting. Against maximum Antarctic or northern adults, which are roughly twice the mass of the confirmed kills, no attack with an observed outcome has been documented. Whether that gap reflects genuine inability, rarity of encounter, or the limits of observation in remote ocean can't be determined from available evidence. The original claim was constructed as a single certainty. The evidence supports something considerably more calibrated. The 3 conclusions the claim bundled together have 3 different answers. 2 have been substantially revised by what happened off Brema Bay between 2019 and 2021. 1 remains genuinely open. The science that bears on this question is named and checkable. Totterdell et al., Marine Mammal Science, 2022. Pittman et al., Marine Mammal Science, 2001. Ford et al., Marine Mammal Science, 2005. Pittman et al., Aquatic Mammals, 2023. Ford and Reeves, Mammal Review, 2008. If you hold documented field observations of orca encounters with adult Antarctic or northern blue whales, outcomes recorded, individuals identified, group size noted, those records would materially advance what the science can say. The Bremer Canyon events happened because researchers were there, with cameras, in the right place, year after year. Most of the world's ocean isn't that.